Today, I want to talk about solving limits in the indeterminate form 1 to the power of infinity. So let's get into it. So here we have our first limit, which is limit as x approaches 0 from the right of 1 plus x to the power of 1 divided by x, right? And if you plug in x here, we'll get 1 to the power of infinity, right? So how do we solve this? Well, what we're going to do is we're going to start off by saying y equals 1 plus x to the power of 1 divided by x. Then, from here, we're going to take the natural log of each side. The natural log of y equals the natural log of 1 plus x, here, x to the power of 1 divided by x, right? Then, we're going to say, what can we do inside this natural log? Well, we can take the power outside the log. So this equals 1 over x times the natural log of 1 plus x, right? Then, what we're going to do is we've done everything we can to this. So we're going to take the limit as x approaches 0 from the right, because that's what's up here, right, of both sides. So the limit as x approaches 0 from the right of y, or sorry, not y, the natural log of y, right, equals the limit as x approaches 0 from the right of this, because this equals the natural log of y, right? 1 over x times the natural log of 1 plus x. Then, from there, what we're going to do is we're going to say, okay, what form is this in? If we plug in 0 here, we get infinity. If we plug in 0, we get the natural log of 1, which just so happens to be 0. So we have infinity times 0. That's not 0, that's an indeterminate form. So we need to rearrange this. So how do we rearrange this? Well, simply, all we need to do is change this from 1 over x times this to this over x, right? So this will equal the limit as x approaches 0 from the right of the natural log of 1 plus x over x. Then, let's try to plug this in. We plug it down here, and we get 0, and we plug it in up here, and we get 0. Now we have 0 over 0. Now we can use L'Hopital's, right? So then, this will equal the limit as x approaches 0 from the right of, take the derivative of this, and you get 1 over 1 plus x. You take the derivative of x, and you get 1. Right? If we plug in 0 here, that'll just give us 1. But that is not our final limit. What we've just found is the limit as x approaches 0 from the right of the natural log of this, but we want the limit as x approaches 0 from the right of just this, right? So how do we do this? Well, what we're going to do is we're going to say this equals L, right? And in order to find this limit, right, this limit up here will be as x approaches 0 from the right of 1 plus x to the power 1 divided by x. This will equal e to the L, okay? And we just found L equals 1. So that's e to the power of 1, which just simply equals e. And that's our final answer. Then let's move up to this one. Now we're going to solve this one the same way. So we're going to start by saying y equals 1 plus 1 over x to the power x. Actually, before we begin, we should ensure that this is 1 to the power infinity, right? Well, we plug it in here, right? And what do we get? Well, we get 0, right? And we plug infinity into here, and we get infinity. So this is 1 to the power of infinity, right? Then we're going to take the natural log of each side. So the natural log of y equals the natural log of 1 plus 1 over x, right? Sorry, yeah. To the power x. Yeah. So then from here, we're going to say, what can we do inside this natural log? Well, we can take out the x. So this equals x times the natural log of 1 plus 1 over x. Okay? Then, now we might be a little stumped, because in the last problem, we had a reciprocal, right? We had 1 over x, and that made it really, really simple for us, right? Actually, sorry, we're not at that step yet. Now we're going to take the limit as x approaches infinity of y, and that'll equal the limit as x approaches infinity of x times the natural log of 1 plus 1 over x, right? So, as I was saying before, right, we might get stumped now, because we saw in the last problem we had this reciprocal we could put under, and that made our life super, super easy. And that's not the case anymore, but so let's take a look at this. Well, we really, really, really want to put it in to a fraction, but we can't really do anything with this natural log. So is there anything we can do with the x, right? And at first glance, you might say, no, there's nothing we can do. Well, there is something we can do. We can change this to the limit as x approaches infinity of the natural log of 1 plus 1 over x over 1 over x, right? Because that's the same thing. Then from here, let's observe what we have. Well, this will be the natural log of 1, right, which is 0, and this will go to 0 as well. Now we have 0 over 0, right? So we can use L'Hopital's. I mean, before we do that, I'm just going to change this to x to the negative 1, right, because that'll make this easier. So then we can say this equals the limit as x approaches, actually also I'm going to change this to x to the negative 1, right, as x approaches infinity, right, of, well, we're going to take the reciprocal of that, 1 over 1 plus x to the negative 1 times derivative of that, right? That'll be negative 1 times x to the negative 2, right, over the derivative of that. What's the derivative of this? Well, that'll be negative 1 times x to the negative 2, right? These will cancel out, and we'll be left with the limit as x approaches infinity, right, of 1 over 1 plus x to the negative 1, right? Now, this also just equals the limit as x approaches infinity of 1 over 1 plus 1 over x, right? This will go to 0, and this will be 1 over 1, which is equals 1. But once again, we're not done. If you take anything away from this video, don't stop at this point. It's very, very crucial to remember that last step where we're going to take this number, which we're going to say equals L, right? And we'll say, here, we'll bring this work up here, right? The limit as x approaches infinity of 1 plus 1 over x to the power x, right? This will equal e to the L, which equals e to the 1, which simply equals e, right? And that's our final answer. Now, in both the examples I just did, we had e as our final answer. That doesn't mean every single problem in the power with the form 1 to the power infinity will have e as its answer, but I thought these were good examples. Thank you for watching my video. Let me know if I said anything wrong or if you have anything additional to add. Have a great day.